Okay, we have done this math. Have we done this math? Okay, we will see this math again if we have done this before, or if not, then we will see this for first time. For series diode configuration of figure 2.13, determine VD, VR, and ID. That means this is your circuit. Here you have a source E, that is 8 volt. Then with this, a diode is forward bias. Then we have a resistor 2.2 kilo ohm, that is your R, and then it come back to the ground. Okay, the voltage of diode is VD, the voltage of resistor is VR. We have to find out VD, obviously. Then we have to find out VR, and we have to find out the ID or IR. Because see, this is only one path. You have only one path for the current to go. So here the current name is ID. That means the diode current. The same current will goes through the resistor. That time it will be called IR. So actually your ID and IR, they are actually same. ID and IR, they are actually same. So whatever you are finding out, they will have the same value. So how to find out? How to find out this? Okay, let's try in this way. So we will do that in this empty space. Now check everyone. So here we will apply a KVL. You know KVL, right? Kirchhoff voltage law. We'll apply a KVL with red. Okay. E, that is this, minus next voltage is your VD. At first we have E minus because that is the source, or if you apply the second, what is the second sign? So plus E minus VD minus VR. So VD minus VR should be equal to 0. So how we got that? E minus VD. So second sign, not first sign. This is our first sign, this is our second sign. So first, second sign, that is plus E minus VD minus VR is equal to 0. So here we know E, that is our 8 volt, minus VD, that should be 0.7. Whatever you have, remember, if this is silicon diode, this is silicon diode, so you will have 0.7. For silicon diode is 0.7 minus VR, because we do not know the VR, is equal to 0. Now take that VR on that side. So you have 8 minus 0.7, that is your 7.3. And take that VR on that side. So this will be plus. So your VR is already done, right? So this is your VD. That means 0.7. So VD is equal to 0.7. So let's write VD is equal to 0.7. And your VR is 7.3. So your VR is equal to 7.3 volt. So that is what you have got. So VD is equal to 0.7 volt, VR is equal to 7.3 volt. Okay. Now let's clear everything. We will find out the current now. Now we need to find out the current. Current means IR or ID. Now the finding out the ID is not easy, but finding out IR is very easy. How? Because this is the current of the resistor. We know the value of the resistor, that is this, and we know the value of the voltage, that is VR. We already know it. So your VR is equal to 7.3 volt. We already found out that, right? We already found that. Now we have to find out the IR. According to the Ohm's law, V is equal to I, R. V is equal to I into R. So you have this I, you have this I, you have this R. So if you multiply these two, current and the resistance, you will get VR. So your IR should be equal to VR divided by R. Understood? VR divided by R. What is your VR? Your VR is 7.3 and your R is 2.2 kilo. Remember, it is in kilo. So it is volt. This is volt. This is in kilo. So this is a good idea to write everything there. Always write your unit, volt, and okay. Let's write it here again. 7.3 volt, 2.2 kilo ohm. Remember one thing, if you divide volt by kilo ohm, your answer will be milliampere. If you divide volt divided by ohm, your answer will be ampere. If you divide volt with mega ohm, your answer will be microampere. Always remember, since our voltage is divided by kilo ohm, so our by default our answer will be milliampere. This is by default. Your answer will be milliampere. Remember, volt divided by kilo ohm. Now then let's divide this. Let's divide this using a calculator. Okay, this is my calculator. You can see, right? Okay, 7.3 divided by 2.2. This is in kilo. Remember, 7.3 divided by 2.2, 3.318. So let's say 3.32. Let's say it is 3.32. That is in milliampere. Remember, 3.32 milliampere. Okay, understood everyone?
Yes, sir.
My Zoom is giving me some trouble. My internet is giving me some trouble. I do not know why. It is constantly disconnecting. So that's why I needed some time to come, right? See, you have seen I was late. I was trying to enter the Zoom from 9:05.
905.
9:05. I was trying. I tried my phone, I tried my computer, I tried my desktop, but nothing was working. Then now you can see it is going down, going down, going down. So I am recording. Hopefully I will give you the record. So stay with me, okay?
Okay.
Okay. Now let's get back. Share the screen. Now the next math. Here they said repeat the example with diode is reversed. Okay, let's do the math. Repeat the example of here with diode is reversed. So how can we do that? So if the diode is reversed, that means I do not know how I am drawing like this. Okay, if your diode is reversed like this, right? That time this will be your minus, this will be your plus, right? No, not like that actually. This is reverse, so we have to apply the KVL here. But remember, if when it is reversed, you do not have any current through this, no current. So at first, your answer will be your ID or IR. At the very beginning, if your diode is reversed, your ID and IR should be equal to zero. Zero current because it is reversed, so no current is going. Since it is 0, so here you will have no voltage because we know your voltage will be, according to the Ohm's law, your voltage should be current means this current IR into R, the resistance. Since your current is 0, your final value will be 0 volt, right? So your VR is 0 volt. Now find out the VD. To find out the VD, okay, let's say your VD plus is here, VD is minus here. So minus, we will not change the plus minus, we'll keep it like that. This is our VD. Now we will apply a KVL here in this side, KVL. So plus E, okay, plus E minus VD. That means this minus part, not the plus, because we are taking the second sign. So plus E minus VD minus VR. We are taking the second sign. So plus E minus VD minus VR should be equal to 0. If it is 0, let's put all the value here. 8 VD we do not know, VD minus VR, VR is 0, is equal to 0. Now take the VD on that side. If you take the VD on that side, so 8 minus 0 is equal to 8 volt. Take the VD on that side. So this is your VD, and that is your final answer. So your IVR was 0 volt. Your ID was 0 milliampere or ampere, whatever you say. And your VD is 8 volt. That is what you got when you apply the diode oppositely or reversely. Okay, that is called reverse bias. So let's check. Yes, your KVL was there. So your VD is 8 volt. Your VD is 8 volt because see, if the diode is reversed, that means your current is 0 ampere. Since your VR is equal to IR into R, so your VR is equal to 0 volt. And if you apply the KVL, you will have 8 volt. See, since there was no current, they actually make it short, make it open, actually open. No diode was there, so they made it open so that it works like an open circuit, and you got whatever voltage you have there, you will get all the voltage there. Okay, this is a simple circuit, simple series diode circuit. I'm sure you can do that. Okay, now the next math, they said let's say determine I, V1, V2, and VO for the series DC configuration. So this is your circuit. You have to find out the I. Which I? This is the I. Then you have to find out the V1. V1. Which one is V1? V1 is the resistor current. The resistor one, no, not current. Resistor voltage. The voltage of the first resistor V1. Then you have to find out the V2. Which one is V2? V2 is the voltage of the resistor 2. That means this one. And you have to find out the VO. VO is a point voltage. Point voltage means you have to find out the voltage of this point regarding or according to the with respect to ground. So there is no ground here. So how can you find out the VO? So we need to introduce a ground here. Where is our ground? Ground is actually connected with the source. So, okay, let's rewrite the circuit or redraw the circuit by using these. So since this is plus 10, so plus will be connected here and the minus will be grounded. So this is your plus 10. So let's write plus, let's write minus. So plus 10 volt. So here you have minus 5. So minus 5 means a minus is connected. So this is 5 volt. This is your minus. This will be your plus. So this is your second voltage source. That means your E2. This will be 5 volt. Since the minus is connected, since it is minus 5 volts, so minus will be connected with the resistor. The plus will be grounded. So that is a pretty simple explanation. So plus 10 volt means plus will be connected. Minus 5 volt means minus will be connected. That's it. Now let's apply a KVL here. If we apply a KVL here, what will happen? So we will start from here, this one. So we will apply the second sign. That means this plus 10 minus V1 minus V2 plus 5. So let's apply. So plus 10 minus V1, then minus V2, then plus 5. Why? Because our second sign is this one. So plus 10 minus V1 minus V2, because we are actually taking the second sign, not the first sign. First sign is ignored. Why is the second sign? This is the second sign, because if we follow the clockwise direction, this is our second, this is our second, this is our second. So this plus 5 will be our second, not the minus, the plus. So this will be plus 5 equal to 0 because our loop is completed. Here we have two unknown, V1 and V2, two unknown. Remember, if we have two unknown, we cannot find out the thing. So what we have to do, we have to convert these into I into R. According to the Ohm's law, your V1 should be I into R. Your V2 should be I into R. Actually, in precise way, it should be I into R1. This one will be I into R1. So your V1 should be equal to I into R1. And your V2 should be I into R2. So here R1 is known 4.7. Your R2 is known 2.2. So let's write I multiplied (4.7). Your I, this one will be I into 2.2. So your this one is V1 is equal to I into 4.7.
Example of the 2.5 umara adina 2.9 usabodana.
Example.
Why you are talking? Do not talk.
Okay.
I lost the thing. So here everything was there. Okay, let's rewrite everything. Do not talk. Do not talk. Now here your E was there. E means actually 10 volt. Means minus V1 minus V2 minus, not minus, it will be plus, remember. So plus is equal to 0. So here 10 will remain as there. 10 plus 5 will be 15. Minus V1 will be I into 4.7 that we already discussed. Minus V2 will be I into 2.2 equal to 0. So from these two thing, we'll take I common. If we take I common, what we have? 15 minus I. If we take I common, this is your I. In bracket, you have 4.7 plus 2.2 equal to 0. Understood? Now take that, the whole thing. Whole thing means,
Sir,
anyone? What happened?
how plus, sir?
Yeah?
How plus come?
Because you are taking minus common, right? Minus I common. Here you have, okay, here you have minus I, here
Yes.
you have minus I. So you're actually taking minus out. Okay, that's why the middle one will be plus.
Okay, sir.
Understood?
Yes.
Okay. Now take the whole thing. That means the whole thing, the minus I 4.7 plus 2.2 on that side, on the other side. So you will have 15 equal to plus. That minus become plus, right? Because you are taking the whole thing out. (4.7) 2.2. Understood? Now here, this thing is known. 4.7 plus 2.2 is actually how much? Maybe how much it is? 6.9 maybe, right? It is 6.9. 4.7 plus 2.2. Yes, actually it is 6.9. So 6.9 kilo ohm, right? You can take this part, only the number. That means 6.9 at the bottom of 15. At the bottom of 15. So you have 15 divided by 6.9. How is 6.9? Because 4.7 plus 2.2 is 6.9. So take that at the bottom of 15. That will give you the value of I. Because I will remain there. 4.7 plus 2.2 becomes 6.9. We will go to the bottom of 15. So 15 divided by 6.9, that is your I. If we have the value in decimal form, 15 divided by 6.9, 2.1739. So let's say 2.174. 2.174. So your value is 2.174. What is the unit? Remember, the 15 was volt. The 15 was volt. And 6.9 was kilo ohm. Why? Because this was kilo ohm. This was kilo ohm. So kilo ohm plus kilo ohm will be kilo ohm. So voltage divided by kilo ohm should be milliampere. So 2.174 milliampere. That is the answer. Okay, let's cancel everything and check whether the answer is correct or not. See, so it is 2.07. Okay, we made a mistake. Yeah, we made a mistake because we forgot. Yeah, we made a mistake, right? See, we made a mistake. We forgot to minus the 0.7. We made a huge mistake here. We forgot about the silicon. right? We forgot about the silicon. Silicon takes 0.7. So let's what is that? Let's correct this one. So here, let's rewrite it again. Let's rewrite. So at first you have 10 volt minus you have V1. V1 is actually I into 4.7. Then you have silicon. Remember, we forgot that previously. We forgot silicon. Silicon is 0.7. Silicon will be always 0.7 diode because it is forward bias. It will be 0.7 minus the next one will be V2. What is your V2? V2 is actually I into 2.2. Then you have plus 5. Plus 5, this one. So plus 5 is equal to 0. Now your this number and this number will give us 10 plus 5, 15, 15 minus 0.7, that means 14.3. So that gives us 14.3, right? And then take these and take these as a common. So I will be common from here. This I and this I will be common. So if we have, if we take that common, minus I in bracket, we have 4.7 plus 2.2 equal to 0. Take that whole thing on the other side. If you take the whole thing on the other side, this will be the thing. Then take this part, that means the 6.9 at the bottom of 14.3. So 14.3, this is volt. 6.9 kilo ohm is equal to your I. What is the value of I now? (14.3) divided by 6.9. Your answer is 2.07. 2.07. Okay, that's right. 2.07 milliampere. So that is the answer. Now your V1 and V2. We have to find out the V1 and V2. How to find out the V1 and V2? So your V1 obviously was I into R1. Your I was 2.07 and your R1 was 4.7. Remember, this is in milli, this is in kilo, so they will give us volt. Milli into kilo, they will give us volt. So 2.07 into 4.7, if we calculate 2.07 into 4.7, this gives us 9.729. 9.729 volt. That is the answer. What is your V2? Your V2 is actually your I into R2 equal to I is equal to 2.07 into 4.7. Remember, this is milliampere. Not 4.7. This should be 2.2 because R2 is 2.2. 2.2 kilo ohm. Now the ohm is critical to write, so you can write kilo ohm like that, or you can write ohm like that. Okay. This gives us 2.07 and 2.2, 4.554. 4.554 volt. That is answer. I think you can see it, right? Now, one critical thing will be your VO. Now, the VO is not that easy to find, not that easy. So what we did first, remember, we redraw the circuit. That was on purpose. This was plus, this was minus, then this was the ground, this was plus, this was minus, because this was minus 5. So this was plus, this was minus. So 5, this was 10. Okay. Now, what I want you to understand, that is, eraser. Okay, what I want you to understand, that is, when we find a point voltage, this voltage is not a point voltage. Remember, this voltage is not a point voltage. This voltage is a what? Is a resistor across voltage. That means 2 volt, right? Here you have a plus, here you have a minus. That means there you have 2 points. That means this is a voltage difference. Here, this is not a point voltage. There are 2 points, plus point and minus point. So you have 2 points. That means this is a voltage difference. Remember, they are actually voltage difference. This one, however, is point voltage. That means you have only 1 point exist, 1 point. Where is the other point? Other point is the ground. That was not given in the circuit. So we made our own ground here. We made our own ground, and we will calculate the voltage according to the ground. So how can we measure the voltage? We need a multimeter. Remember, we need a multimeter like this. You know multimeter, what multimeter does, right? You know it. This is the multimeter. Remember, you have 1 point. So that is a plus point. And you have another point. That is your black point, right? So plus is red, the black is the minus. So what you do, you take cable, right? You take cable, you want to measure the voltage of this point. This is your point, right? So you want to take the cable and place it here. You will place it here. And you will take the black cable and you will place it where? To the ground, because this is only 1 point voltage. This is the ground. You place it there. So you have, okay, somebody wants to. So this is the multimeter. So you place the red pin there where you want to measure the voltage, and you place the black pin to the ground, right? So now what you are actually measuring in between these 2 points, what you are measuring? You are actually measuring, okay, who is drawing that? Do not draw. What you are actually measuring? You are actually measuring these and these. So these are the two things you have in between. These are the two things you have in between these 2 points, right? Two things you have in between in your point. So these two will be added. These two will be added because these two are in between your red pin and the black pin. So you have your V2 and you have your what is that? Your 5 volt. But what will be the sign? What will be their sign? That is the question. Now check this one. Check this one out. So red pin is close to plus V2. So this one will be our sign. Remember, this one will be our sign because our plus red is close to plus. So this one will be our sign. So plus V2. And since this is our first sign, this is our first sign, so we will consider the first sign. So plus V2 minus 5. That will be our voltage. That will be our VO. Remember that. So plus V2 minus 5, that will be our voltage. Why? Because this is plus, the red is plus, the red is close to the plus sign. So our plus and plus, they matches, right? So plus and plus. So this will be our sign. So second sign, first sign is plus. So plus V2, so minus 5. Plus V2 minus 5. Okay. So plus V2 minus 5. So this is your VO plus V2. What was the V2? The V2 was 2.017. What was the current? I forgot. What was the current? Yeah, 2.07, not 0.17. Okay. Your current was 2.07 actually into 2.2. So 4.554, that was your V2, right? Remember? Volt minus 5. So your actual result is 4.554 minus 5. So it will have a minus in front of it, 0.446. Okay, let's say 0.45. So that is your VO. Okay. So you have understood why we have plus V2 and minus 5, because these two are in between your plus pin and the black pin. That is the red pin and the black pin in between. So they will be counted. So why V2 is plus and 5 is minus? Because your red pin is close to the sign of V2, that is your sign. So plus V2. And since this is the first sign, so we will consider the first sign. So plus V2 minus 5. First sign equal to first sign. So we'll consider the first sign here. So let's check the answer. You can see the value is 2.07, 9.73, 4.55 that we already calculated. And your final answer will be 0. Okay, minus 0.45 that we have found. We have just found. Okay. Okay. When is our next class?
Wednesday.
Wednesday. Wednesday we will be doing half wave rectifier and the full wave rectifier. Rectifiers. Okay.
Okay, sir.
We will do the rectifiers, and I will give you one software by which you can check any circuit at your home.
Checking.
Yeah, checking what is the value, what is the answer, everything.
Oh, that's
Okay, you can analyze your circuit there. Understood?
yeah.
Yes, sir.
Okay. So until next time, bye for now.
Inshallah.
Okay. See you Wednesday.
Thank you, sir.
Stay home, okay? Stay home, stay safe.
Okay, sir. Allah Hafiz.
Okay.